All right, today's lesson is on deductive reasoning. Deductive reasoning, unlike inductive reasoning, you actually use known facts to reach a conclusion. In inductive reasoning, you make an educated guess. When you use deduction, you look at the facts, whatever they are, and you make a decision based upon those facts. We're going to start off today's lesson by reviewing the term converse. I want you to write the converse of each conditional statement that is given. So the statement, if I am thirsty, then I drink water, we would rewrite that as, if I drink water, then I am thirsty. Remember the converse, you just take the hypothesis and make it the conclusion. Take the conclusion and make it the hypothesis. Number two, if the car outside is wet, then it rained. It would be, if it rained, then the car outside is wet. Our vocabulary word for today, new vocabulary word is deduce. Related words are deductive, which is the adjective, or deduction, which is a noun. You make a deduction. To deduce is to use known facts to reach a conclusion. So you use general principles and facts to come up to a conclusion, and you deduce the conclusion. So we're going to be using deductive reasoning when we do proofs in geometry. So let's use our vocabulary that we have learned. Get this out of the way. Complete each statement with a word from the list. Use each word only once. You use blank reasoning to draw a conclusion. So it'd be deductive reasoning to draw a conclusion based on facts. The conclusion of your reasoning is a deduction, and the teacher will not deduce that a dog ate your homework. So, because the dog can't eat the computer as you're watching this video, which is your homework. As we continue on, we're going to talk about two laws or properties that have to do with deductive reasoning. The first law is called the law of detachment. The law of detachment is simply true. If the hypothesis of a true conditional is true, then the conclusion is also true. What does that mean? If the statement P implies Q is a true statement and P is true, then Q must also be true. So let's look at using the law of detachment in a problem. What can you conclude from the given information? If there is lightning, then it is not safe to be out in the open. Marla sees lightning from the soccer field. Underline the hypothesis of the conditional and circle the conclusion. If there is lightning, hypothesis follows the if statement, then it is not safe to be out in the open. It is not safe to be out in the open would be the conclusion. So now we're going to underline the correct word or phrase to complete each sentence. Marla sees lightning from the soccer field fits the hypothesis of the conditional. Therefore, is it safe or is it not safe to be on the soccer field? It is not safe to be on the soccer field. Based off of her hypothesis of a true conditional statement, we can assume that the conclusion that it's not safe to be out on the soccer field is a true statement also. So this is the law of detachment. Another law is the law of syllogism. You can state a conclusion from let's try that again. You can state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. So this is sort of like the transitive property. If P implies Q is true and Q implies R is true, we can say that P implies R is true also. So let's look at each conclusion. If it is July, then you are on summer vacation. If you are on summer vacation, then you work in a smoothie shop. So the conclusion I can reach is, if it is July, then you work in a smoothie shop. Let's look at problem number 10. If a figure is a rhombus, then it has four sides. If a figure has four sides, then it is a quadrilateral. So we can reach the conclusion, if a figure is a rhombus, then it is a quadrilateral. So the law of syllogism basically says if A implies B, B implies C, then A implies C is true also. So all three statements will be true. So what can we conclude from the given information? Let's use the law of syllogism. What is your reasoning? as you do this. Think about what your reasoning is as you do this problem. If a number ends in 0, then it is divisible by 10. If a number is divisible by 10, then it is divisible by 5. Our P, Q, we have to identify a P, Q, and R for this statement. The P statement is a number ends in 0. The Q statement will be a number is divisible by 10. And the R statement is a number is divisible by 5. Decide whether each part of the given information is true or false. Write T for true or F for false. Does P imply Q? If a number ends in 0, then it is divisible by 10. That is true. Does Q imply R? If a number is divisible by 10, then it is divisible by 5. That is also true. So therefore, if a number ends in 0, it is divisible by 5. So circle the part of the law of syllogism you will write. So we're given P implies Q, we're given Q implies R, so our conclusion will be P implies R. So if a number ends in 0, then it is divisible by 5. Let's continue on looking at another problem using these two laws. Sometimes you can use the law of syllogism and the law of detachment together. What can you conclude from the given information? And again, think about your reasoning as we do this problem. If a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. The Nile is 4,132 miles long. So we're given 3 different things to deal with in this problem. First, we have to identify P, Q, and R in the given information. So our P statement is a river is more than 4,000 miles long. Our Q statement will be a river is longer than the Amazon. And then our R statement will be it is the longest river in the world. So using the law of syllogism to complete the conditional, if a river is more than 4,000 miles long, then it is the longest river in the world. We can use that statement to use the law of detachment to get a conditional. Let's try again. You can use the law of detachment and the conditional in exercise 16 to write a conclusion. The Nile is the longest river in the world. So that's using the laws of syllogism and the law of detachment together. Please, if you have notes on this, write them down. Questions, we'll go over it tomorrow in class. But if this is, please make sure you understand that P implies Q, Q implies R, therefore P implies R. P implies R is a true statement. The statement that the Nile is 4,132 miles long is a true statement, so I can say that the Nile is the longest river in the world. So let's check our lesson that we did today. If possible, make a conclusion from the given true statements and what reasoning did you use. If a figure is a 3-sided polygon, then it is a triangle. Figure ABC is a 3-sided polygon. So our P sentence is a figure is a 3-sided polygon, and our Q statement is it is a triangle. We're going to underline the correct words to complete each sentence. The second statement matches the hypothesis, okay, of the first statement. I can use the law of detachment to state a conclusion. What is the conclusion going to be? If a figure is a 3-sided polygon, then it is a triangle. Figure ABC is a 3-sided polygon, so figure ABC is a triangle. Let's look at one more lesson check here. Do you understand? What is the error in the reasoning below? Birds that weigh more than 50 pounds cannot fly. A kiwi cannot fly, so a kiwi weighs more than 50 pounds. Right? Birds that weigh more than 50 pounds cannot fly as a conditional. So if a bird weighs more than 50 pounds, that bird cannot fly. Or if a bird weighs more than 50 pounds, then it cannot fly. The hypothesis of this conditional is a bird weighs more than 50 pounds. A kiwi cannot fly matches the conclusion of the conditional because a kiwi cannot fly. A kiwi does not weigh more than 50 pounds, but it cannot fly. So the student incorrectly applied the law of detachment in this problem. I have overgone my time. It is over. I went over by 30 minutes. You know, hey, I'm talking slow. My voice is rough. But that is your lesson for today. If you have any questions, please write them down and we'll go over them in class tomorrow. Have a good evening. Talk to you tomorrow.